Hi everyone, this is our look at cycloalkanes. This is a kind of a compound that's very similar to an alkane. The only thing is there's a ring structure in it. We still have single bonded carbons, just like we would have for an alkane, but this time those single bonded carbons all connect together in a ring structure, a cyclical structure. This cyclical structure is going to have one of these stereotypical geometric shapes. If there's 3 carbons, a triangle, 4 carbons, a square, a pentagon, a hexagon. We're not going to see 7, thank goodness, an 8, an octagon. We're also not going to see rings of 9 or 10. These compounds, they have the general formula CnH2n. It's important to highlight for the future that this is the same general formula as alkenes. So, a structure like this might be one of these shapes. If there are no branches at all, it will be one of these 5 shapes. If there was a branch, a methyl or an ethyl attached, it might look something like one of these 2 down here. Our naming rules are very similar, but we have some extra things to add on to from our work with linear alkanes. We notice this carbon-to-carbon single bond, and so the name ends with ane, A-N-E. We're going to use a prefix for the carbons in the ring. 3 is prop, but, pent for 5, hex for 6, and oct for 8. Use a prefix. Then add cyclo. These are cycloalkanes, so not only do the names end with ane, they also have this syllable, I guess it's 2 syllables, cyclo, right in the name as well. If there are any alkyl groups, branches, we're going to still name them the same way as we've already established. If there's 1 carbon in the branch, it's methyl. If there's 2 carbons in the branch, it's ethyl. If there's 3 carbons, propyl. If we have 2 of the same kind of a branch, 2 methyls, we'll name that as dimethyl. If there's 3 of the same trimethyl, we're going to name different kinds of branches alphabetically. Ethyl always comes before methyl. The numbering system, though, is a little bit different. If there is only 1 branch, just 1 methyl, or just 1 ethyl, there's going to be no number. There is not going to be a digit to show us the location of that branch. If there's 2 or more branches, we're going to start our numbering process at a branch. Doesn't matter which position it happens to be, doesn't matter which branch it is, carbon number 1 is going to be at the branch. And then we're going to count clockwise or counterclockwise to find the location of the other branches. Again, the trick here is the digits we arrive at, we want to make them as small as possible. In the next video, we're going to be doing some examples, but here, a few quick ones. These ones do not have any branches, so we're just going to follow our first 3 rules. This one is cyclopropane. It's a ring structure, cyclo, with 3 carbons, prop, single bonded ane. Cyclopropane, cyclobutane, cyclopentane, 6 carbons in a ring, cyclohexane. This one is cyclooctane. It is possible that there would be a methyl, maybe even 2 methyls in the compound. We're going to see a bunch of those examples in the next video, and I hope that helps.